First of all, I want to recognize our Spotlight Students of the Week. This week, we have 2 students who are getting this honor, right? So in total, I received 27 submissions. Among the perfect scorers, the fastest one is Roger. Roger Yo, is Roger here?
Mm-hmm.
Yeah, can you briefly introduce yourself and talk about your favorite thing about math?
I'm Roger. I'm in 8th grade. I go to Commute House, and my favorite subject is probability, I think. Yeah.
Oh, okay. So you're probably right. You like probability. Great. I want to mention that this is a historical week. This week we have the first ever student who got this spotlight student twice. That's Roger. I believe Roger also got this recognition in the second week. So you know, he's setting a record now. He's the only student so far getting this honor twice. Right. There's another spotlight student I want to recognize. His name is Kyle Liao. Kyle is the only elementary school student so far getting this recognition at level M, middle school level. So Kyle, are you on the line?
Yes.
Can you introduce yourself and your favorite things about math?
My name is Kyle, and I don't really know what to choose as my favorite subject in math.
Oh, you don't know?
Yes.
So everything is your favorite?
What?
Everything about math is your favorite?
Well, not everything. I kind of like geometry and I guess.
Okay, you like geometry. Okay.
And
And what?
variable.
Variables. Okay, I guess it's algebra. So Kyle is actually a third grader. So this is, in my opinion, very remarkable. Kyle, as a third grader, getting this recognition at middle school level. So congratulations to both Kyle and Roger. Okay, let's get back to our business. We'll first talk about these 3 problems. Among the 27 submissions, 7 of them perfect scorers. Okay, among these 7, 2 of them are elementary school students. So one is Kyle, the other one is Chauncey. Is Chauncey on the call as well?
Yes.
So can I give you problem number 1? Because you are also one of the fastest one to figure out problem number 1. I mean, several of you guys get the first problem done correctly within 1 minute. But since Chauncey, you're an elementary school student, you're a perfect scorer, so I'd like to give you this opportunity to talk about problem number 1, how you solve problem number 1.
Okay. So how I did this was I evaluated everyone. So I first saw if Kyle was wrong, then if he has at least 70 cars, it has to be more than that. And then 58 cards, it has to be more than that, so it can be infinite number. So if Kyle was, so then if Isaac was wrong, then
Hold on.
Yes.
Pause, please. So let's go over your strategy first. So your strategy is go by this solution. Go by the question. The question is if exactly one of them is wrong or is false. So you started with Kyle. So you assume Kyle is wrong, and then you want to see what happened if Kyle is wrong. So then you say, okay, if Kyle is wrong, that means Leo does not have at most 65 cars. Means Leo had more than 65 cars, right?
yes.
Then what about the other 2 conditions? So if Leo has more than 65 cars, what happened to the other 2 conditions? So they can both be right?
Mm-hmm.
So then what is the smallest number in this case if Kyle is wrong?
It has to at least be 70, just 70. And that's still a lot.
All right, so Chauncey said if Kyle is wrong, then in that situation, the smallest number of cars Leo can have is 70, right? Good, so this is the first step. You got 70, and then keep going.
So then I tried Isaac. So then if he was wrong, then at most it will be 65, but he would at least have 58. So then he has to, he can't have 65 or over. So then he has to at least have 58. So then the smallest would actually just be 58.
So if Isaac is wrong, so the condition is Leo has at least 70 cards. So if that is wrong, that means, so Leo has at least 70 cards means greater than or equal to 70, right? So if Isaac is wrong, means Leo has no more than 69 cards, correct?
Yeah.
Right. So if Leo has no more than 69 cards, and if Isaac is the only one is wrong, then the other two, both of the other two person, Kyle and both the other two person are right. So Kyle is right at most 65, and Dr. Hong is right. Leo has at least 58. So that means what? That means Leo has the smallest number of cards Leo may have is 58, correct?
Yeah.
All right. So keep going.
So then I tried Dr. Hong. So if he was wrong, then at most 65 cards, but Isaac says that he has at least 70, so it wouldn't work for both of them, so it's totally wrong.
All right. So that means Dr. Hong cannot be wrong, right? So
Yeah.
that's this problem. No, just kidding. So what Chauncey is saying, if Dr. Hong is wrong, so Dr. Hong's statement was Leo has at least 58 cards. So if he's wrong, that means Leo has no more than 57 cards, correct?
Yes.
So if Leo has no more than 57 cards, that means Isaac is wrong, and well, Kyle is right. So that means Isaac is wrong too. So it means Dr. Hong is not the only person who is wrong, right? So
yes,
that means Dr. Hong is contradict to the condition. Exactly one of them is false. So based on this analysis, we can figure out how many. What's the smallest number of cards Leo has?
then it will be 58 from
58.
the 70 and 58. Yeah.
Correct. So the answer to problem number 1 is 58. Okay. Good job, Chauncey. I want to hear others. Anyone had the easier way to solve this problem? Okay, Leo, you just raise your hand. Okay, go ahead.
Well, I saw that there was at least 58 and at least 70, and I saw that 58 was smaller, so I chose that it was at least 58, and I saw there was also at most 65, and 58 and 65 like to work together. So I just saw that like 70, if 70 at least 70 cards was wrong, then it could be then it could be a minimum of 58.
Oh, okay. So what Leo is saying, well, let me just elaborate what he just said. I hope I caught his method right. So basically, he was looking at these numbers. So he looked at these numbers: 58, 70, and 65. Of course, they're at least, or at most, right? So he just started with the smallest number because the question was asking for the smallest number of cards you can have, right? So he just started with 58 because it's at least 58. So he just tried to make it, just say, let's see, what if Leo just had 58 cards? And then he figured out, then if that's the case, then Isaac is wrong. Then both Kyle and Dr. Hong can be right. Then they come to a 58. So that's why it's 58, right? Good. So I think that's probably the fastest way to figure this out. So for this specific problem, if you go with the question asking you exactly one of them is false, and you go statement by statement, well, you can get to the answer just like what Chauncey did. That's a good approach. Okay, that's a legitimate approach. But a shortcut is just go by the numbers. You look at these numbers, there are a few options, then go by the smallest one because the question was asking for the smallest one. Then, reverse, go back and see, hey, which one can be right, which one can be wrong. Then you can easily find that 58, okay? All right, anything else? Any other comments? All right, so let's move on to problem number 2. I ask you to calculate square root of 2 plus square root of 3 plus the square root of 2 minus square root of 3. Okay, let me use my notepad. Okay, 2 plus, is that plus or minus?
Plus.
Plus, okay. 2 minus square root of 3. Okay, so I want to give this question to deserve to answer one of these questions. And he answered this question rather fast. Considering he's only third grade, that's even more impressive. So I want to hear from
Okay, so I set A to the first one, which is 2 plus the square root of 3 square rooted. And
Okay,
then
so you said this one is A.
and then the other one is B.
Okay, the other one is B. Okay.
So I thought, what's A squared plus B squared?
Okay, you try to figure out A squared plus B squared, right?
That equals 2 plus the square root of 3 plus 2 minus the square root of 3. Cancel the square root of 3 out because
Right. Yeah, let's slow down for now. So A squared is basically square root of 2 plus square root of 3 squared. Okay, this is basically what A squared is. And because it's square root of something and then to the square, so then all you need just to get rid of the square root, right? So get rid of square root and get rid of this square. So you got 2 plus square root of 3, and the same apply to B, okay? And then you cancel the square root of 3, so you get 2 plus 2 is 4, okay? Good.
yeah. So now I thought, what's A plus B squared?
Okay, so you want to calculate what? A plus B
Squared. So it was first you open the parentheses. So it's A times A, or A squared,
Mhm.
plus AB plus BA plus B squared.
Mhm. Yeah, this is what I talked about in one of the first meetups. So I showed you a geometric interpretation of multiplication, right? So this is basically what I discussed earlier on, I think a couple weeks ago. Okay, good. And then
So this A squared plus B squared, there's an extra 2AB in there. So
A squared, B squared, you already got it, right? It was 4, right?
yeah. So
Okay.
so A plus B squared equaled 4 plus 2AB.
Okay, 4 plus 2AB.
So now I thought, what's 2AB?
Okay,
For
you
that,
try to figure out 2AB.
for then you would need to solve AB.
Okay, what is AB?
AB equals the square is just like 2 plus the square root of 3 square rooted times 2 plus minus the square root of 3 square rooted.
Okay. This would equal to what? A square root of 2
2 plus 3 times 2 minus 3.
2 minus square root of 3, right?
Mm-hmm.
And then this equal to what?
2 squared minus 2 times square root of 3 plus the 2 times the square root of 3 minus the square root of 3 squared, which is 3.
So this is basically, one of those, another thing, x plus y times x minus y equals x squared minus y squared, right? So this is 2 plus square root of 3 times 2 minus square root of 3 is 2 squared minus square root of 3 squared. So this is 1, right?
1.
Okay.
So then I did 1 times 2 because of 2AB
2AB got 2 plus 4 plus 2 and
is
6.
6. And then
Right.
you have to have 6 square rooted because because 6 is A plus B squared.
Very good. So now you get A plus B equals square root of 6. So let me ask you, can this be negative square root of 6? Because you're saying A plus B squared is 6, right? So if a plus b squared is 6, it could be, square root of 6 or a negative square root of 6. Can this be negative?
I haven't thought of that.
Can someone answer the question?
This can't be negative.
So who is speaking?
Oh, David.
I'm sorry?
David.
Damon?
Yeah.
Okay, so please explain why.
Okay, so we first see that the square root of 3 is larger than 1. So the square root of 2 plus square root of 3 must be positive and larger than
Yeah.
1. And
So
then
both numbers are positive. So the addition of them must be positive too. So that's why a plus b cannot be negative. Okay, good job, guys. For this specific problem, let me go over this, add a few comments, okay?
Look, can I say what I did?
Oh, okay. Is that Roger?
Mm-hmm.
Okay, go ahead.
I just set it equal to x, like the
Okay.
whole thing equal to x, and I just squared both sides. So it would be
Okay.
a squared plus 2ab plus b squared. So you have 2 plus square root of 3 plus 2 minus square root of 3, and the square root of 3's cancel out. And then
Okay,
you
hold
have
on.
2 times.
Sorry, slow down. So you make
Okay.
this one equal to x, and you
Mhm.
square both sides. Okay, you square both sides, right? And then this one will be 2 plus square root of 3 minus, plus. Okay, sorry. 2 times 2 plus square root of 3 times 2 minus square root of 3 plus 2 minus square root of 3, right?
Mm-hmm.
I just added parentheses just to make it clear, equals x squared, right? And then you cancel the square root of 3's.
Mm-hmm.
And then this one in the middle is 1. So you did 2 minus 2 plus
Or 2 plus
2
2.
minus 2 plus 2. Hold on. Oh, plus, sorry, because it's plus. 2 plus 2 plus 2 equals x squared. And x equals square root of 6, right?
Mm-hmm.
Good job, right? So I want to add a few things about this. I want to add a comment about this. So if you were working on this problem and you didn't think of this, say, a plus b squared or a squared, a squared minus b squared equals a plus b times a minus b. How do we get started, right? Where do we start when solving this problem? I think it's important because this problem is probably one of the easier ones among similar type of problems. So I think in the future weeks, I'll give you a more detailed version of this. So hopefully you can solve this. But for this specific problem, I asked you to calculate these two funky numbers, add together, right? So you look at these two numbers, they're 2 and square root of 3. I mean, they seem to have some relationship, but not, you may not be very clear at the beginning. But how do you figure out? Look at these square roots. Every time you see square roots, okay, you try to break it. You try to take away square root. How to take away a square root? So that's how, that should be the first hint or the first question you ask yourself. So if I were working on this problem, I would think about it, how can I take away these square roots? Okay, the easiest way to take away square roots is to square them, right? So the easiest way to take away square root is to square them. So then what I will do is I will do what Roger did, just square the whole thing and then see what I got, right? So I square the whole thing. Again, this is what I will get using this approach. Again, Kyle's approach is brilliant too. Okay, all right. So just to give you an idea how to start, where you start for a problem like this. Okay. All right. So let's move on to next problem. Okay. Most students had the next problem wrong. Okay. So let's read this. I want to give this to Roger because Roger is the other spotlight student. But let me first read the problem first. Okay. So A, B, C, D, E, F is a hexagon, and I gave you midpoint for each side of this hexagon. And then I also told you M is a point inside this A, B, C, D, E, F. And then I said connecting M to these midpoints, dissect the hexagon into 6 smaller quadrilaterals. And then I gave you some areas of these quadrilaterals, and then ask you what's the remaining area of the quadrilateral. Okay, so let me go back to my notepad. You may have noticed that every time I gave you a geometry problem, I didn't draw you a figure yet. I described the problem for you. So this is part of things I like you to be familiar with. So not every time you get a figure. So when you read something, when you read a text, I like you to construct this figure in your brain. Okay. So that's part of things I like to train you guys on. All right. So when you get this description of the problem, so you have to be able to draw it. Okay. Preferably draw it in your brain. Of course, if you have a pencil and paper, draw it on pencil. You draw it on a paper using a pencil. That's fine too. Okay. I want to give this to Roger, but let me draw this hexagon first. Okay. So first of all, it's a B, C, D, E, F. So I'll just do A, B, C, D, E, F. Okay. This may or may not be a regular hexagon. Okay. I think my original description was wrong. I put a regular hexagon there, and then I changed it. I sent it to the parents, corrected. So let's do A, B, C, D, E, F. And then I said G, H, I, J, K, L are midpoints. So G, H, I, J, K, and L. They are midpoints. Okay. And then I said there is a point M, and M may not be the center of A, B, C, D, F. It could be just anywhere. So let me just draw M here. This is M. Okay. And you connect M to all these midpoints. Okay. Okay, you connect M to these midpoints. You get this 1, 2, 3, 4, 5, 6 smaller quadrilaterals. Okay. And then I said I gave you the areas of these quadrilaterals. So starting from vertex A, go clockwise. So 81, 64, 49, 36, 25. Okay. So most of you gave me an answer of 16. Most of you gave me an answer of 16. I guess you look at these numbers, 81, 64, 49, 36, 25. You find a pattern. 81 is 9 square, 64 is 8 square, 49 is 7 square, 36 is 6 square, 25 is 5 square. And you thought maybe the last one is 4 square. And actually, this is not the right answer. Okay, so I'll leave it to Roger. Roger is the fastest one to get this question right. I think he spent like a minute on this question. That's about the speed I can get, right? So I look, if I read this problem and I do it, it probably take me about a minute. And Roger did it as fast as I did. So great job. Please, Roger, tell us what you did.
Okay, so like I drew another line connecting to each vertice.
Okay, so Roger drew another line connecting M to each vertices. Okay. M to A, M to B, M to C, M to D, M to E, M to F. Okay.
And then I labeled like the two like triangles inside of like the unknown one, X and X.
So you said which one is X?
It's like CFM and then
No,
KFM.
you mean LFM?
Oh yeah, L. Okay.
Okay. So you label this one as what?
X, I'm pretty sure.
Okay.
And then.
How about FMK? How about FMK?
I think I also labeled that as X. Yeah.
Wait, they may not be equal.
Not on that. No, I'm forgetting. No, I went like around the whole circle. So I said like LAM was 81 minus X. Or no, not. I mean, no. Okay, I meant LAM is X because they're triangles that share the same base and height. So then that's also X.
Okay, so this is a very important step. Okay, for this problem, you're calculating an area of an irregular quadrilateral. Okay, this may or may not be a square, may or may not be a rectangle, may or may not be a parallelogram. This may not be anything. This is just a irregular quadrilateral. So what Roger did was first he connected M with each vertices, and then he started label. He started label half of this. Well, not half. Part of this as X. Part of this quadrilateral as X. And then he noticed that L is the midpoint of AF, right? L is the midpoint of AF. And ALM and FLM, these two triangles share the same vertex M, and they have the same base. Okay, the base is the same. AL equal to LF, right? So AML must be X. Good. Keep going.
And then, so then the next one will be 81 minus X.
Okay, so the
And then the
next
other will
one
be
is
81 minus
81 mince X. And then,
Mhm.
then this one will be
Also 81
minus X, the same idea, right?
Mhm.
AGM and BGM, they are the same size, the same area because their base is the same and they share the same third vertex, okay? And then keep going.
And then negative 16, no, negative 17 plus X. And
Okay, so
negative
this
17 plus X.
BMH will be 64 minus 81 minus X. So this is negative 17 plus X, right?
Mhm.
And then the same size as HMC, that will be negative 17 plus X. Good. Keep going.
And then you do 49 minus that, which would be 66 minus X.
Okay, this will be 66 minus X. And then this one will be the same, right? The DIM will be the same size. And then
Then you
how about
get, next one is negative 30 plus X.
this will be 36 minus 66 minus X. This will be negative 30 plus X, right? And then the same size as this one, right? The same
And
size
then
as MEJ, okay?
the next two are 55 minus X.
Okay, 25 minus negative 30 plus, this will be 55 minus X and the same size as this, okay?
And you can see in like the quadrilateral that you don't know, when you
Mhm.
add the two pieces up, the X's cancel out and you get 55.
X plus 55 minus X equal to 55. That's the answer, 55. Okay? Any questions or comments on this one? Is there another solution on this one? Oh, Leo, you have a different solution?
Well,
Hold on. Do you need me to redraw this?
yeah.
Okay, so let me redraw this. A, B, C, D, E, F. Okay. A, B, C, D, E, F, G, H, I, J, K, L. I'll do M. Okay. Yeah, Leo, go ahead.
And then I kind of saw the same thing, did the same thing as Roger. Like I saw that two triangles that share the same base will be equal. So so I kind of just like saw like just like saw the areas and then like kind of like put a random number for FM triangle FML.
Okay, you put a random number here. FML. What number did you put there?
I think it was 30 something.
30? Okay, so let's just do 30. Okay.
And then I started and then after that I started filling out all the other triangles.
Okay, so you after 30, you do 30, and then this will be 81 minus 30, 51, 51, 64 minus 51, that'll be 13, 13. This will be 49 minus 13, that'll be 36, 36. So this will be 36 minus 36, this will be 0, right? And 0. So this will be 25 minus 0, this will be 25, 25, okay? And then add them together, you got 55?
Yeah.
Oh, okay.
And then I saw that like if I added 1 to LFM or subtracted 1 that I would still get 55 because like I kind of did plus like I kind of went in a cycle and did +1 plus
All right, so what you did was for 30, you add 1 or subtract 1, and you want to see the difference. And then you find every time, if you're 30, you change 30 to 31, and then at the end, you got 24. If you change 30 to 29, at the end, you got 26. So the sum of them is the same. Okay, cool. That's another good way of solving this. Any other solution on this problem?
Me.
Kyle, okay, go ahead. Do you need me to redraw this?
Kinda, yeah.
Okay. Can you quickly redraw it? Yeah,
So I
keep
just
going.
did first I just did the same steps as Roger.
You connect
So
to all these midpoint and the vertices. Okay.
and then into the middle of
Okay.
like that.
Okay.
And I realized the same thing that F, N, and like A, G, and M are and A and G, B, M have the same area as they share the same base and height.
Okay.
So, and that's the same for every other ones in the hexagon. So I called A, G, M, and G, B, M, N.
Let me mute you guys. I think some of you didn't mute yourself. There are a lot of background noise. Okay, now it's better. Okay, keep going.
So, I called A, G, M, and G, B, M, N. And then B, H, M, and H, C, M, O. And so on. The next one's P. Wait, are you writing?
No. Say again.
So AGM and GBM are both N.
N, okay.
Both of them. And then for the next triangle, it's the same O and O, P and P.
Okay. Q
and Q. R and R.
S,
and
S. Okay.
So S plus R, which is FKML, is what we're trying to say. Get what is that? It's 81 plus 25 minus N plus Q.
That was sort of my solution. So you're saying this is 81 plus 25 minus N
plus Q.
Okay.
N plus Q is 36 plus 64 minus P plus O.
Okay, N plus Q is 64 plus what?
36.
36 minus O plus P, right?
O plus P is 49.
This is 49. So N plus Q is 100 minus 51. Okay. So this is 106 minus 51. This is 55. Good? All right. This is the same as my method. All right. So I think that's all what I can think of. Anything else? Okay. By the way, I know this is a level M class. So I already told your parents, I assigned a level E problem yesterday or the day before yesterday. And that level E problem, the problem set were fairly difficult, especially one of the problems are very difficult. I encourage all of you to go there and solve the level E problems as well for this week, for the coming week. So let's see who can get them all correct, right? So who can get perfect score on that set. As I said, that set is, one of the problems are very difficult. So please try to go there and challenge yourself and see who can get those answers quickly. Okay. I have to confess that for one of those problems, it took me several minutes to solve it. So that's not a 1 minute problem for me. So I bet it will take you a long time. So let's see who can beat me. Okay, that's it. So I will see you next week. Okay, bye bye.
Oh, 111.